Hello, my name is Nurain.
Hello, my name is Wan Heng Membijahe by Ismail Sahimi, and I will explain to you about the electropneumatic circuit for this lab from 4.0 until 4.3. Okay, there are some component or device that we are using for example, double acting cylinder, one-way flow control valve, 5-way solenoid valve, 5-way impulse solenoid valve, and we are using a push button, and then we are using a D10 switch. Okay, let me explain to you for 4.1 circuit control for sustained output using push button, and then we can see the simulation for this circuit. Okay, when PB1 press, the cylinder extend and retract when PB1 was released. Okay, pressing the PB1 results in closing the circuit, allows the current through relay actives electromechanical part inside it, then turn on the valve solenoid Y1. Valve solenoid generate the electromagnetic field to shift the spool wall inside 5-way solenoid valve to left side. Compressed air supply will fill up into double acting cylinder through the one-way flow control valve. The one-way flow control valve regulates the flow rate of compressed air flow to fill up the volume of cylinder. The cylinder will fully extend if PB1 press for a while for the volume area filled up by the airflow. When PB1 release, the circuit will be open from spring release, cause the relay will turn off and shift the spool wall inside the 5-way solenoid valve to initial position due to the spring. It is allow the compressed airflow to fully retract the cylinder. Okay, we look forward for the second circuit, 4.2 circuit control for sustained output using D10 switch. Okay, they are basically the same circuit like 4.1, but have a little bit different for the switch. We are using D10 switch. Okay, as we can look for the simulation circuit. Okay, when switch 1 press, the cylinder will be fully extending and hold on state that position until switch 1 is pressing again to fully retract. It is because of different behavior between push button and D10 switch for the same sustain type valve. Okay, as we can look, pressing the D10 switch results in closing circuit, allows the current through the relay K2, actives the electromechanical part inside it. To close the relay switch contact K2 and turn on the valve solenoid Y2. The valve solenoid generate the electromagnetic field to shift the spool wall inside the 5-way solenoid valve to the left side. Compressed air supply will fill up into the double acting cylinder through the one-way flow control valve. One-way flow control valve regulates the flow rate of compressed air flow to fill up the volume area of cylinder. The cylinder will fully retract if switch 1 is pressing for a second time to change to off state that initial position. It is causing the relay will turn off and shift the spool wall inside the 5-way solenoid valve to the initial position due to the spring. It is allows compressed airflow to fully retract the cylinder. Okay, for the next circuit, 4.3 non-sustained type output. Okay, for this circuit, we are using 5-way impulse valve, which is can shift the spool wall inside it for both position without spring, and it can hold for that position. Okay, as we can see for the simulation circuit, once the PB2 was pressed, the cylinder fully extend and hold on that position until PB3 being pressing to fully retract. Pressing the PB2 results in closing the circuit, allows the current through the relay K3, actives the electromechanical part inside it. To close the relay, switch contact K3 and turn on the valve solenoid Y3. The valve solenoid generate electromagnetic field to shift the spool wall inside 5-way impulse solenoid valve to the left side. Compressed air supply will fill up into double acting cylinder through the one-way flow control valve. One-way flow control valve regulates the flow rate of compressed air flow to fill up the volume area of cylinder. When PB3 pressed, the current flow through the relay K4 and energize the relay switch contact K4 to on the valve solenoid Y4. It change the 5-way impulse solenoid valve to the initial position, right side, and allow the compressed airflow to fully retract the cylinder.
So, for figure 4.4, holding circuit for sustained output, I will explain the operation of the electro-pneumatic circuit. When PB start is pressed, cylinder is extended. Since PB start allow the current flow through the relay K5 and energize the relay switch contact K5 to on the valve solenoid Y5. K5 relay is self-latching and will only disconnected when PB stop is pressed. 5-way impulse solenoid valve will change the position to allow compressed air supply into double acting cylinder through one-way flow control valve, causing the cylinder to extend. One-way flow control valve regulates the flow rate of compressed air flow to fill up the volume area of cylinder. When PB stop is pressed, which is normally close contact, it will open the circuit connection. Hence, the relay will turn off and change the 5-way solenoid valve to initial position due to the spring, allowing compressed airflow to fully retract the cylinder. Lastly, for figure 4.5, roller and proximity sensor in electro-pneumatic, I will also explain the operation of the electro-pneumatic circuit. When PB start is pressed, cylinder is extended and retracted back to back. Cylinder stop moving when PB stop is pressed. Since PB start allow the current flow through the relay K6, K7 and K8. K6 relay is self-latching and will only disconnect when PB stop is pressed. Roller switch is connected to switch K7 while K7 energizes the relay switch contact Y6. Proximity sensor is connected to switch K8 while K8 energizes the relay switch contact Y7. Both relay switch contact K7 and K8 to on the valve solenoid Y6 and Y7 respectively. 5/2-way impulse solenoid valve will change the position to allow compressed air supply into double acting cylinder through the one-way flow control valve, causing the cylinder to extend and retract continuously. One-way flow control valve regulate the flow rate of compressed air flow to fill up the volume area of cylinder. When PB stop is pressed, which is normally close contact, it will open the circuit connection. Hence, the cylinder is back to original position of retracted.